Hello, everyone, and welcome to today's webinar. We are having one of our partners, Golioth, and they will talk through their how you can accelerate your next connected product with Golioth's end-to-end reference designs. So, just introducing who will present the webinar today. I'll be your host. My name is Tiago Montt. I'm a developer marketing manager here at Nordic Semiconductor. I won't be doing much of the talking. That will be with Chris and Mike's. So Chris, they're both from Golioth, of course. Chris is an electrical engineer, podcaster, design consultant from based in Durham, North Carolina. He's been in the electronics industry for over 20 years, working at multiple companies. You might know him if you're into podcasts, running the Empower podcast. He's been doing that for more than 10 years, having a lot of guests over that time. And Mike is a developer relations engineer at Golioth. He's been tinkering with microcontrollers, since the early 2000s. Spent 12 years at Hackaday, 8 of those as the editor-in-chief. And on the side, he's also an orchestra musician in Madison, Wisconsin. Okay, so quick run through of the agenda. We'll give a quick intro to Nordic cellular IoT solutions. So that will be my part, about 5 to 6 minutes, and then I'll hand it over to Chris and Mike to introduce Golioth and go through the meat of this webinar, where they show us their end-to-end cellular IoT reference designs based on the nRF9160 device. Specifically, they'll show a air quality monitor, CAN asset tracker, and Modbus vibration monitor, and then after that, we'll have the Q&A then. All right, so if I had to summarize Nordic's cellular solution in one picture, this would be it. So we provide a complete solution for cellular IoT development that comprises of the hardware. So that will be the SIPs with the nRF91 series, also the certified LTE stacks. Then we have the higher layer of software in the NRF Connect SDK. So all the IP connectivity that you need, everything, the modem library, all the middleware, file systems, and so on. A lot of tools to help you develop and troubleshoot your issues and get faster to market with a solid solution. And also, of course, everyone needs to learn when they're getting started, whether it's something new or something they even have worked with previously. And for that, we have our Dev Academy, so our online learning platform. Support is on DevZone. And of course, there are always things that Nordic cannot support customers directly with. And for that, we have our partner program, which Golioth is a part of, to help you with things that you might need that Nordic cannot provide. And then we also have our NRF Cloud services with the device management, location services, and security services to help you deploy and maintain your device throughout its lifecycle. So normally, how cellular IoT device has been done in, if you call it a traditional way, is that you have sort of a piecemeal approach. For the cellular part, you of course have the module, right? And then you'll have a host MCU driving that. RF front end, if you need location capabilities, you'll have a GNSS module on the side. For storing your security, your credentials, your keys, you'll have a secure element, and then you'll have a PMIC managing the power for all those parts. What Nordic has been doing is, over time, Nordic's history has always been about ultra-low power and integration of functionality. So that's the story is not much different on the cellular IoT side. So we put all these blocks into one unified SIP nRF91 series device. Everything is integrated in there. And this solves a lot of issues, but one of the most important ones is that in this traditional approach, there's a fragmented ownership. So you have one company providing the chipset, one company providing the module, and then you'll have another company for the MCU, PMIC, security element, and so on. When you run into issues or you have technical difficulties, this creates a lot of points of contact, especially on the cellular side. Often, there's a tug of war between module maker, chipset maker to figure out where the issue is. You need to ship your devices to the manufacturer to troubleshoot. With Nordic, it's a single point of contact. So we're trying to, first of all, lower the cost because, typically the side effect of integration is that you have lower cost. Of course, simplifying supply chain, you go from multiple lines in your BOM to one nRF91 series device. And of course, all the lower complexity, lower power, smaller size, all of those things are coming as an additional benefit. And also with our tooling, we strive to give all the all the leverage to our developers to troubleshoot things by themselves. So we have the cellular monitor, which allows you to trace the cellular connectivity. So when you have an issue, you don't really need to ship your hardware to us. You can just trace the cellular communication, hand over that trace to someone on tech support on DevZone, and that will speed up the debugging process a lot compared to some other module vendors or cellular IoT vendors out there in the market. And of course, this global certification is really important because we have one part number multiple products within the NRF91 series, which are globally certified, which means you can have one global SKU and you can deploy that on a global scale. So the portfolio on the NRF91 series today, the first product we launched into the market already back in 2018 was the NRF9160. So this is a dual mode device. It supports both NB-IoT as well as LTM, and it's fully integrated from S-Market. This means that it has all these certifications so you can deploy globally. So this complies with the 3GPP release 13. This is a mature product. It's been proven. We have hundreds of customers. I'll show a couple of examples in a few slides. And yeah, it's a solution that we'll continue to maintain for years to come. But there's some updates in the NRF91 series. So the first one, well, actually, before I go into the individual differences, the biggest change on all these three is that they are now compliant with the 3GPP release 14. And they will have some specific Nordic features in each of them. They're also all software compatible. So, if you start with the NRF9161, which is available today, but you actually want to move to the 9151 as an example, all the work that you're putting into the software today will be fully reusable. So they have the same modem firmware is shared across these three devices. So let me start then with the NRF9161. So in addition to the 3GPP release 14 uplift, this also brings support for DECT NR+, and it's again a fully certified global SIP. Then we have the NRF9151 that we announced in around February this year. This is expected to be available sometime this year. Just like the 61, it also brings support for DECT NR+, with some additional benefits. So it has a 20% smaller footprint. It supports both Power Class 3 and Power Class 5, so 20 dBm support, which means that you have lower power consumption peaks when you do the radioactivity. And this is extremely important when it comes to selecting your battery, because sometimes it gives you a wider selection because it relaxes the requirements for battery selection, as you don't need to serve such high peaks. So it lowers the current peaks in about 40%. It also aligns with our supply chain resilience that we're implementing at Nordic. And again, fully integrated for mass market means you have all the components in the SIP and it's globally certified. Then we have the NRF9131. Again, support for NR+, as well as NB-IoT and LTM. The difference, these are, the comparisons are to scale. Why it's smaller is because it doesn't have the PMIC and it doesn't have the passives and crystals. And what that means is that, so this is the part that's, very, very good for NR+, and for cellular IoT, it's not pre-certified. So this is for customers that have really, really high volumes, and they can do the certification themselves. So because they will, of course, provide reference designs to speed up that process, but it doesn't have as much integration as the 9151 and the 9161, and of course the 9160 that came before those. Yeah, and before I hand it over to our partners at Golioth, just wanted to show two devices that were really only possible with the NRF91 series devices. The first one is a bird tracker. This is only 2.5 grams, and this is not a typo. This is used to track animals as small as 40 grams, and this was at the time of this was designed, the NRF9160 was the lightest and the smallest device that it could find on the market. And of course, it doesn't require an extra host microcontroller. That was really important because every milligram counts in this design, and the fact that you had one device where you could run both the application as well as have the modem and all the connectivity, all the peripherals, onboard flash, RAM was really key for this design. So this highlights sort of the integration level that we provide at Nordic. And then we have another design from Honeywell. In this case, they were able to reduce the cost by 50%. So again, what we discussed in the last few slides about integration, driving down costs, helping with inventory management, supply chain really played a critical role for this design over here. Yeah, so that's the end of my part. As I said, it was going to be short. I'll hand it over to Chris and Mike on Golioth to walk us through their end-to-end reference designs. Thanks, and I'll get back at the end of the webinar.
Thanks, Tiago. We're really glad to be here with all the Nordic community and everybody who's interested in reference designs. We are going to be talking about end-to-end reference designs today. My name is Chris Gamble, and I'm here with my coworker, Mike Stish. Mike, how you doing?
I'm doing well. How are you, Chris?
Yeah, good. Reference designs are things that Mike and I do just about every day at Golioth. That's part of our role in developer relations. But Golioth itself is an IoT SaaS platform. And so we are here to talk a little bit about that in addition to the reference designs that you're going to see on the screen. Basically, it's a cloud-side service. That is really the thing that Golioth builds for users and maintains. But then we also enable you through things like a device-side SDK, which is cross-platform, but works really, really well with NRF Connect SDK as well. And so you're going to see a lot of that here today. So between the device side, the hardware that Nordic provides, the NRF Connect SDK, which Golioth builds on top of, the cloud side capabilities, and then visualization from either open source tools like we're going to show you today, or a wide range of other things. Maybe you have a cloud team that works in AWS or Azure or Google Cloud. All of these things are we're going to show how it goes end to end and how all this stuff can work together. So let's talk about the agenda real quick. First, we're going to show you a demo and show you an actual reference design. Then we're going to show you how you can replicate this on your bench, because that's really the important thing, so that you can get up and going quickly. Then we're going to show you how you can extend this to custom hardware, because that's what we work really well with custom hardware. And most people, once you get outside of just a single dev board, it's not that useful. You're not going to put that into production. You're not going to put that out in the field. You want to make sure that your custom hardware can also work. And then in an IoT system, one thing we always talk about is kind of the data is the product, as much as it pains me as a hardware engineer to say that, but the hardware, data is the product. And so we're going to talk about how you can take that data and you can extend it and send it to different places and do interesting things with it. But specifically, you as the hardware firmware engineer can do it yourself, because that's one thing that I personally feel really enabled by. Mike, can you tell us a little bit what a reference design is and how you and I are very enabled by Golioth in the first place? Because I don't think any of this stuff would have been possible in my former life before Golioth.
Yeah, I think one of the really cool things is the things that firmware would think was hard, which is networking, encryption, sending data, getting control back from the network, are all kind of taken care of for you. But you have to figure out how to put them into the project that you have in mind. And so we really designed these reference designs to look at different use cases that companies might have, to get something that's close to what you're looking for, that you can start from. It has hardware that you can buy off the shelf right now. It has open source firmware that you can download and run and get things up in maybe an afternoon. So if you need to just validate it for yourself, or if you're looking at a customer that needs to sign off on it, you can not only get like a proof of concept that works really well, but it will be easy to customize that to make it look like you did a ton of work to get to that point, even though you didn't.
Yep. All right, so let's dive into our first demo here. So one thing you're going to see is if I just put the camera on myself, as I want to do. So you'll see a lot of stuff that looks like this, and this is what we call the IODL platform, but really it's just, you think of it as just custom hardware that you might also be building on your own side. This one specifically has a PCB front panel with some backlit LEDs, e-papers, things like that. That's actually not, that is peripheral. It's not even running Zephyr on there. That's actually just a peripheral. Zephyr is all running on an NRF 9160 custom board that we built here. And the key thing is that there are click headers so that you can use the microelectronica click ecosystem, so microbus and all the click headers that are out there. And this one is just talking to a bunch of sensors. You're going to see a bunch of different sensors that we have, sensors and really interfaces that we have here. And then processing that data on the NRF 9160, sending it to the cloud over cellular. And that's really going to be the basis for a lot of what we're talking about here today. In terms of the actual data, once it gets to the cloud, so let's take a look at this. So this is some of the data we have coming live off of a device. I have it over there. It's actually not that specific device I was showing. This is a DK, and we'll tell you a little bit more about that. So what you can see here is you can see the device that we're talking about, and this is actually a NRF9160 DK. We'll show you how the hardware is kind of a little bit different when it's on a DK versus that custom hardware I was showing up there, or holding up there. And you can see down here that it's the status and the last report that's happening here, and setting sync, things like that. Going over some other capabilities that we're going to be talking through today. One very important one is that you can't talk to Golioth unless you're doing so securely using DTLS and PSK ID and PSK. PSK is pre-shared key, and that's because basically the cloud is provisioning a credential for you, passing it down to the device, and then you program that onto the device. That's really the easiest way to get started. We also have certificates, though, which are a little bit more involved, but ultimately what you're going to be doing as you go into production. We also have over-the-air update capabilities that we'll talk about a little bit later, but this one is running version 1.2.0 of this firmware. LightDB state, this is actually just showing some of the default stuff in the template that Mike's going to be talking about here in a little bit. And then as we start getting kind of the good stuff here, this is really the data that is streaming back here and what we're seeing. And so this data is kind of folded up right now. But if we look at an individual packet, you can see all of the sensor data that's coming off this specific device. So we got CO2, humidity, pressure, temperature, and then a bunch of particulate stuff coming off the particulate monitor that's there. Another thing that we love about Zephyr.
Can you scroll in a little bit so we can see that data a little bit better, and then maybe just cover what the sensors are and the roles in this particular reference design that we're seeing?
Yes, good call. Good call. Yeah, so hopefully this is a little bit more viewable now. But yes, the CO2 level, right? So this is actually the Sensirion SCD41. And then we have a BME 280 on board. That's doing the humidity, temperature, and pressure. And so this is kilopascals, I believe, and Celsius. And this is just percentage. And then finally, particulate monitoring. That's often 2.5 micron and 10 micron. So it's the size of the particulate. It's actually the SPS 30 from Sensirion. And so it's basically a fan, like an intake fan, and then laser lights showing you how big the particulates that are going through there. And then so it's showing you basically if you had, so say I was, a smoker and I was smoking right now, you would see different size particulates going through the fan, and you'd be able to tell that sort of thing. Probably not just measuring, it's not measuring smokers. It's probably, you'd want to use this in, pollution context out in the, if you have live near a busy road or things like that.
Manufacturing context, you might want to tell, like, are your machines putting off a lot of particulate matter, or like how clean is your air in your guest rooms at your hotel, or like there's just a ton of uses for this.
Yeah, good call. Good call. Another thing that we love about Zephyr is we ultimately, NRF Connect SDK is built on top of Zephyr, and it's got a great logging subsystem. Golioth actually has something that ties right into there and offers an alternative backend. And so basically, when we're connected to the Golioth cloud, we're sending our logs directly back to the Golioth cloud, and we're able to see that here. We can do some filtering based on different log levels and things like that as well. Settings is cloud to device capability. And so now this is I'm on the Golioth cloud. I want to tell this thing to go from taking a reading every 10 seconds to every 30 seconds. Well, I can do that just right here. Hit enter. You see that this is going to say it's out of sync, but it's actually sending that data down to the device. And once it's synchronized, it actually, you can see that all of the readings just synchronized. And what you also see is that there's different scope. And so this is actually, even all of these devices, they all have these capabilities here. These are all programmed in at the fleet level, but the individual setting is actually being set for this specific device that we're looking at here. And then finally, remote procedure calls. These are capabilities where you might want to call a function remotely. So one that's on this specific device is to go and clean the particulate sensor. And all that is just a little subroutine that spins up the fan really fast. You could trigger that from here. But other ones that we have that are kind of generic into the reference design template is something like get network info. So this is calling down to the device, and it's really just saying, go call the modem info library. And it packages up that data, sends it back. My connection here is not super great. So you see it took 6 seconds round trip, but that's because of my slow cell service here. But it's the device itself that's saying, hey, here's all the things that I got from modem info, and it's sending that stuff back. Great for troubleshooting though, and being able to pull this stuff back here. ultimately, this data is now, you saw the LightDB stream data, and you saw that it's kind of formatted, and in here, it's a time series data. But if I want to go and then actually pull this data out and make it useful and visual for someone else, if I want to communicate to a team member or my boss, or I want to show this on a report, I might use something like Grafana, which is a visualization platform. And so this is a open source tool that's used for. And so this is an open source tool that makes it easy to kind of visualize a lot of different data that ties into the Golioth REST API backend. And in doing so, basically, we're just going and querying over a certain time span. This one is actually 15 minutes, but it's actually, you see that there's different times here that's calculated in there. And all it's doing is doing a REST API call. It's doing a post and saying, here's the range of data I want, pulls that data back, puts it onto a chart. And you'll see different examples of this. Basically just makes it a little bit easier to go and visualize this data for your customers, for your boss, or even just for troubleshooting.
Yeah, and I always like to point out that everything that you see on the Golioth web console is available through our REST API. So any of the control or any of the data that you want to get at through your own cloud platform or your customer app or any of that is available with REST API calls.
Yep, that's a really good point. And you could start to imagine scripting that as well. So there's how many? 2, 4, 6, 8 devices in this project. So this fleet has 8. If I wanted to go clean all 8 particulate monitors, I would go and basically I could script just say, give me all the devices, and then run through that array of devices and call that function on all 8 devices, get the responses, that sort of thing. So it's something you might be doing on a more custom basis. And there's a lot of different tools you can do at this point. Basically, at this point, you're kind of in the realm of, your cloud engineers, maybe your front end people. It's all REST APIs talking to one another at this point. So it's very familiar to the web enabled folks in your organization. It might be someone who's just making an app. It might be someone who is more Kubernetes capable sort of thing. But basically, at this point, this is how a lot of the rest of the cloud works. And from our perspective as hardware and firmware developers, we get to work in the world of constrained devices and optimizing battery and simplified interfaces up to the cloud. The cloud engineers then get to cloud and front end, and database engineers get to think about this now as not having to control a piece of hardware that's out in the field. They just interact with the data that's there, and that's been a really, really useful interface between the two different teams and kind of archetypes of people there.
That messy middle that we talk about kind of brings the two sets of engineers together, and not a tear was shed.
That's right. Exactly. Yeah. It's gotten a lot easier. So,
yeah.
All right, let's talk a little bit more about some of the other designs so we'll see just a real quick recap of this design. You'll see some QR codes here. So if you want to scan those, or some short codes, if you wanted to go and look through them. Basically, this is what this one has on it. So we're measuring those things we talked about. This one's pretty straightforward. It's really grabbing the sensor data. It is using the Zephyr's sensor subsystem, which Mike has written some great blog posts about. We use it all the time here. So, looking at that as an example of how you might go and tie into other sensors. So say you find another sensor that's in the Zephyr tree, you could go and kind of utilize it, pull a different characteristic. Like there's different characteristics in the sensor subsystem, right?
Yeah, that's right. So basically you have like the channels, which is an abstraction layer for each type of data. So Chris is using, 5 or more channels here. For instance, like the BME 280 has 3 channels. It's got an ambient temperature, a pressure, and humidity channel on it. But I think there's maybe 128 channels that are specified, and then you can make custom channels on top of that. Under the hood, though, it's just basically the drivers calling into an API. So it's pretty easy for you to take a sensor that's not in Zephyr and put it in and have the same kind of abstracted calls to it from your C code, so that if in a future rev you decide to use a different sensor that provides the same type of data, you can do that without making big changes to your C code.
Yep. Yeah. And so this is really, the monitor, you see the monitor moniker. We call a lot of our reference designs to have monitor on the back, because in those cases, usually it's a pretty straightforward application of take a sensor reading, push it to the cloud, maybe have some data coming back down to the device. In the next one, we actually show that it's actually an asset tracker. And that's because, well, one of those sensors in this case is actually a GPS unit. We actually do use one that's external to the NRF 9160. And that's for cross-platform reasons and also because of the update rate that we're usually tracking. So this is specifically for being in a car, right? We want to track the OBD2 characteristics that are there. So VSS, vehicle speed sensor, and that's at a specific address. We're using, we actually tie it into the OBD2 connector there. In the upper right, what you see is actually, that's a simulator plugged into the other side, but you could go and plug it into your car as well. And that's what one of our engineers actually did. That's what's showing on the map there. And the other thing that's interesting, so if you're going and you're scanning this QR code, you want to go and look at the open source firmware that's attached to this project. You'll also see things like, Mike, you wrote in there to have it cache every 30 seconds. Why did you do that sort of thing?
Yeah, so like a lot of customers are really concerned about like their power budget. So they have a battery, they don't want to be connected to the cell network the whole time. Or maybe you're on a moving vehicle, like a shipping container, and you go through tunnels or in other places where you don't have connectivity. Having the device on and trying to phone home during all that is really expensive. And so it's really easy to just cache the GPS readings at any interval that you want, until you get to a certain percentage of your space that's full or whatnot, and then try to log on to the cell network at that point and send them up to the cloud. I think really just about any data is great for that. We do have the ability with Golioth, if you're just sending like a temperature reading and nothing else, Golioth will timestamp that when it gets to the server. But that's for right. I'd say maybe the majority of sensor use cases for our customers, they're wanting to put their own timestamp on it. And as long as the data comes in with that timestamp, Golioth will recognize that and categorize it. Or, of course, Golioth has the ability to route that data from the device anywhere you want it, so your own servers can use those timestamps.
Yeah, you will even see the delta of like when the timestamp is received, if it has a timestamp. When the data packet was received, and then you'll see when the timestamp was taken on the device side as well. So you could start to do deltas if you really wanted to, but most of the time you just want to be able to time correlate it. In this case, what we're showing is we're time correlating the vehicle speed with the actual location, and then you can go and map that data to an actual map and show that we're driving around a neighborhood. And you can see in the upper right there's the speed. And so you can even see things like, you could infer things like, oh, actually the speed dropped to a certain low level for amount of time. That's probably a stop sign. And actually, when you zoom in on that area, it's like, oh no, that's exactly where a stop sign is. So you could start to really calculate a lot of interesting data there as well. That is a industrial bus. I mean, that's using CAN. This is another one where we have Modbus now. And so this one's a vibration monitor where we have an off-the-shelf banner sensor. This is normally a sensor that you would have in a industrial environment. It's high reliability. It's very well temperature rated, things like that. This is something you would attach to the side of like an AC induction motor. And then you just want to know when this thing's shaking around too much. It's really predictive maintenance instead of preventative maintenance. And that's what we talk about in one of the videos that you see on that QR code there as well. And you would want to do that because you could start, preventative maintenance is kind of the standard way of doing things, like every 6 months, but then you could start to see problems early if there were early problems, so you don't miss it if you're only checking every 6 months. Or if you really want to start to cost optimize, you also could maybe stretch it further until you start to see problems showing up in the data, and then you start to see that as well. And so we pull data off of there that, as a electrical engineer, I don't quite understand, like kurtosis and different peak frequencies and things like that, mechanical things that motor folks know much better than I do. But at a certain point, it is a Modbus based sensor. So there's a mapping of the different characteristics that coming out of that sensor, including temperature and acceleration on different axes. And then we're pulling that out over Modbus using the Zephyr Modbus driver, using an RS-485 click header that's plugged in there, and then pulling that data back and sending it up to the cloud, and then visualizing it like we have done with a lot of this other stuff. Again, this data, it's a pretty simple mapping on the visualization side of things. However, it doesn't stop there. It could go into your TinyML type of, or actually it wouldn't even be TinyML at that point. You could just start to put that into different AI expert systems and things like that, or you could send it off to your business development, your business software and things like that, and really start to collate that data and start to make actionable data based on inferred results instead of just the raw data as well. And that's a really super useful thing. It's making a thing that's out in the field that is connected to the cloud, but then all of that data, like I said, the data is the product. And then ultimately that product can go a lot of different places. And there's probably other people in your organization that are hungry for that data, including those brand shiny new AI models that love to do that sort of thing.
Data is the soup du jour of our society.
That is. That's right. Yep. All right, Mike, take it away. Why don't you start showing people how we can replicate this stuff and talking about follow-along hardware.
All right, so all of these reference designs, the one that we've talked about, the ones we haven't talked about, they are open source, and we showed you custom hardware that we use to demo these, but at the heart of them, you can just buy off-the-shelf hardware. And you can see in each of these 3 pictures, we are showing the big blue board is, you should be familiar with it already. It's the Nordic NRF 9160 development kit. And we've just used the Arduino header footprint that's on that and a little adapter board to add different sensors to this. So you can order, if you don't have a development board, get the development kit, order a couple sensors that match, figure out which of our reference designs are closest to those sensors that you need to do, and you're off to the races. And, it doesn't have to be the same sensors. So Chris was just showing Modbus, and before that showing CAN bus. Like if you're using one of those buses, start from there, and you're just kind of snipping out a little bit between like what part, device address, and then how you want to format the data, and everything before that, and everything, connection and encryption and everything after that, sending it is already done for you, which is pretty nice. I do just have in front of me an NRF 9160 DK. It's got nothing on it. So I'm going to run the reference design template, which is kind of the origin of all these reference designs. They build on top of that. Instead of reading from a sensor, I'm just incrementing a counter and then sending that as our sensor data from there on out. All over, we do a lot of work with DigiKey, as I'm sure the rest of you do, and finding those boards, putting them all in one shopping cart and getting them onto your desk is a really quick way for you to get up and running. The other thing is I always like to start from known working firmware for anything. So if I'm doing a proof of concept, even if I already have my custom hardware in hand, I will generally start with a board that is like I've gotten to work before. And so that's a great place to start from. Head over to the Golioth reference designs. You can find them at projects.golioth.io and find your way to the GitHub. From there, you can just download a precompiled binary. So you don't even need Zephyr at the start. We have it set up so that Zephyr is a great shell. If you haven't worked with it before, you can just open a serial connection to your device and put in your credentials, and you'll be up and running on your project incredibly quickly.
Yeah, just to put a finer point on that. So the steps to replicate that sort of thing would be basically buy the parts like we showed on DigiKey. Those are all on those pages. So if you scroll back a little bit, you'll see Mike doesn't have to scroll back. Sorry, I meant scroll back in the video. You can see those QR codes, or go to projects.golioth.io. This is where all of this documentation is. And ultimately, then there's a parts list. You buy all that stuff, plug it all together, download the binary. And so, I mean, from box arriving at your house to like getting something connecting to Golioth, 10 minutes. I mean, that sort of thing. And then you have a working reference design on your desk. And that's the known good kind of piece of it. And then ultimately, then this is the basis from which you can extend these things.
Yeah, and I mean, we've tested this out with actual people who don't work for Golioth. We do a free Zephyr training every month, and this is exactly how we do it. We start from a precompiled binary. They buy a board, they load that binary and get up and running, and then from there, use that platform to kind of learn Zephyr and learn a little bit more about implementing their own hardware. So, if you need a demo now, this is the route.
And it's so nice too. Like when I don't know about you, Mike, but as a hardware engineer learning firmware broadly and maybe Zephyr more specifically, like having that known good to go back to, like when I'm beating my head against the desk and be like, why doesn't this work? And then I go back to the known good firmware and then that also doesn't work. Well, then I know something's wrong. And then I realize I probably unplugged the SIM card or I didn't turn on the board or something like that. Right. The usual boneheaded moves that I do, but ultimately having that known good and having that kind of sanity check is so important to my sanity. Yeah.
And I'm with you. The UICC error, that means you didn't plug in your SIM card.
Yeah. Yeah. Yep. Okay, so next step is to actually take the stuff we're talking about, right? So we're talking about reference designs, we're talking about follow along hardware, and then we're going to actually show you what it looks like kind of to take this and extend it, right?
That's right. So let's dig into the firmware. I think one of the things to realize is that Nordic already has some really great tools for you working with the NRF Connect SDK, which is itself based on Zephyr. And so I'm going to go a little bit over the Visual Studio Code route for this. We are fortunate enough to be central partners with Nordic. We have some of these reference designs in the project manifest, I think they call it already.
It's the add-ons,
so,
the SDK
the add-ons.
add-ons.
Okay, there you go.
Yeah. Yep.
So this is VS Code. You should be pretty familiar with it. If you haven't installed the Nordic NRF Connect extension, you should. So there's Connect for VS Code, but there's also this extension pack, which comes with a whole bunch of other stuff. So I'd recommend installing the extension pack so you have everything. And so when you first load this up, you will have the option here of a new NRF Connect SDK application, and that should open a thing up here. There it goes. All right. Browse application index. That's what I was thinking of, the application index. And you'll see right here, it comes up. There's some Golioth stuff right under here. You could search for Golioth. The air quality monitor that Chris was showing off at the beginning is here, and a CAN bus is right here. I'm going to do the reference design template because that's the hardware that I have connected up. It's then going to ask you which release that you want, and I'm going to pick the newest release. And then it's also going to ask for a place that you want to put this. I'm not going to go through this right now because what it will do then is it will pull in all of the dependencies, and that will take, I don't know, 8 or 10 minutes. So do this and then go grab a coffee and come back. I'm just going to open a folder because I did this ahead of time. Right.
Yeah. And we should mention too, the reason Mike said that it'll take a little bit different. It is a little bit different in that we actually treat Zephyr and NRF Connect SDK as a dependency in a lot of our designs. And there's a lot of reasons to do that. Mike has a great article called Manifest Sanity in Ever-Changing World. Highly recommend that talk. Great blog post, great talk that Mike did at Embedded Open Source Summit. And ultimately, we do that as a dependency so that when you so if Mike hands me a project and all the code that's in it, I can actually just do a West init with the manifest that's tied to that project. And ultimately, it'll pull in all the things, all the dependencies in that case, including Zephyr, tagged to a very specific version. And when we think about how we expect people to be working in a production environment with the rest of their, with multiple teams and things like that, you don't want Zephyr or NCS in your repository. You don't want to be, have someone fiddling around with NCS in the background and then you break your build for some reason. You want to have a very well-known version, and treating it as a dependency really, really helps that.
Yeah, and so you can look at, once this loads up, you'll get an app folder that has the contents of the repository that you were checking out. And there's a west.yaml, that's what's called the manifest file that we base everything on. It'll show you like what version of Golioth you're on and any of the other dependencies that are pulled in. And of course, then you can add your own modules in here, whatever you need to do with your project. The nice thing about having this plugin is it gives you a lot of options here. Like here are all our basic actions like build, debug, flash, work with the device tree, everything that kind of gets you into the guts. But I think Nordic has a lot of great resources for learning about this tool. So I'll direct you to the Nordic Dev Academy and other resources there. I think today we're just going to kind of jump in to the little bit about the way that Golioth works. So Golioth is a module that gets built on top of NCS or NRF Connect SDK for Zephyr. And the kind of the magic of that is you turn on some kconfig and you put a header include at the top of your file, and then you're able to start calling API calls. So with Golioth, we basically create a context here that has the credentials for logging into Golioth, and then we create a client, and then that client gets passed to everything. So for instance, here this sets up a callback that says, hey, whenever Golioth connects or disconnects, I want you to run this function. And then from there, we're off to the races with all of the services. So for instance, Chris mentioned the ability to do over-the-air firmware updates. Basically, all you have to do is call this one API call that gives it your current version number, which is defined further up in this file, and that client that we created before. And then the device will register as soon as it gets a connection with the Golioth servers, and the Golioth servers say, okay, anytime we have a new firmware version for you, I'm going to send you the version number, and you can decide whether you want to download it or not. The same is true for all of the other data files. So one of the things that I think is super useful is that ability to send time stream data. We have an app sensors.file in app sensors.c file in here. And, we're doing some stuff to actually read from the sensors. And then like this SNPrintK is like formatting it into JSON format. Of course, you have your option of using JSON or CBOR or just raw bytes, which we call octet stream. But just for the demonstration here, I'm using JSON. And then I have this one function call that basically says send this data to Golioth. So this one's an async call. We also have synchronous calls. That client that I showed being created further, I give that to it, and then it knows like how to encrypt the channel and who to send the data to. I give it a path. So in this case, I'm giving it a sensor to the path, and then I tell it, here's my JSON type that I'm sending. And then I've just got the data itself, the length of the data, and a callback for once the data has been sent to Golioth, so that I can either handle an error, or if it's successful, maybe I want to clear out some memory. And if we look at the devices, I have one of these running right now. This is the Golioth web console right now. I can see that my device last reported a few seconds ago. And if I go to the stream data, we can see here's that sensor path that we put in the API call. And then the data, like I said before, I don't have a real sensor hooked up to this. So we're just incrementing a counter, and I'm sending that counter data, and it appears on Golioth, which is pretty magical.
Yes. And one nice thing too is that one of the things I always struggle about when I'm kind of piecing together different sample pieces of sample code, things like that, I mostly just want to see like, where can I stick my data? So like if you were following along with the reference design template and you just wanted to shove data somewhere, go search for the counter, put your data there, right? It might be a variable, it might be stuff coming back from the sensor subsystem, but ultimately I just want to know, where can I put that data so that it gets shuttled up to the cloud?
Yeah, and your first proof of concept doesn't have to use the sensor subsystem. Like if you have a C library that already works, you can just do that C library and then put the data into your JSON or CBOR packet, or stream some raw bytes and get it sent. I also think looking at the remote procedure call is a good one. So similar, remote procedure call is actually observing data. So it's kind of like the OTA. You have to tell the server, like, hey, I'm a device, and I want you to tell me whenever you get a remote procedure call for me.
Hit me back. Hit me back, server. Hit me back.
Yeah. So if I go down to the bottom here, I'm actually setting up 3 of these calls, and you can see they're all pretty simple to set up. So again, there's a context for this one, and I give it the client that we had before, and that's how it knows how to authenticate and where to send the data. And then that context just gets passed as the first argument in one of these API calls. This is actually the name of the method. So you saw Chris earlier on the RPC call get network info. So that's where that puts it. And then this is the callback that is going to happen when the data comes back. So this call right here says to the server, whenever you see something coming for me called get network info, then run this callback. And if I go up to, there's a simpler callback up here. Actually, that I'm thinking about settings. So I got to switch context in my mind to RPC. So reboot. So Chris was calling reboot before. There is a reboot handler. Sorry, folks, right here on reboot. All right. So that's the function that we're looking for. And in this case, it just submits a piece of work that we've previously told Zephyr about. And then it sends this return message. That Golioth OK is what the server will get back. And if there was a problem with the way that this message came in, you can send a different error message, and then the server will also get that. So in the case of remote procedure calls, if I send, you don't really want to send reboot, but if I send like,
what about set log levels? Is that in there?
Yeah, it is. But I also don't want to do that right now. Let's just do get network info. And I think if we do it with the right spelling and a parameter, we'll probably get an error here, because we're going to try and call a method. Looks like it doesn't check. I don't have it set to check for that, but it should be able to check for that method and say, hey, I didn't expect for you to give me any data in it. And the other thing is you can send things back. So all this information came back, and that was in the callback for this larger one up here, like onset log level. I actually put some different information into a CBOR packet that we then send back, and that comes back with the okay. Maybe a little bit too in depth for right now on that. I think the settings is a little bit easier to understand.
Is that this is all open source. People can dig into their heart's delight or follow our training. They'll show up at our trainings. We'll talk about.
Yeah, and I often say to people, like, even if you're not going to use Golioth, like having all of these examples out here when you're trying to figure out how to do something with Zephyr is handy. Like I'm looking up these reference designs when I'm doing other projects, and not necessarily for the Golioth parts of it. Like, how do I do a work queue in Zephyr? You know, stuff like that. So this is the setting service. So very similar to RPC, the device has to tell the server like, hey, I'm expecting some settings to come. So if you get some, hit me back in Chris's vernacular. And so in this case, very similar, you're going to have one function call. This one is a special function call because it's going to have the added benefit of bounding the value for it. It's going to make sure that it's an integer, and it's going to make sure that it's within a set range. So I set up a context again, just by giving the client to it so it knows how to encrypt and where to send the data. Here's that context. We then tell it, this is the setting name. So loop delay S is what's on the Golioth server. We say there's a minimum and a maximum value that this can be. And if it's out of those ranges, then don't do that. And then call this setting on the other side. And the nice thing about having a function like this is look how easy our callback is up here. So our callback, we already know that it's an integer within the range that we expect it to. So we can just set our new value there. You can log it if you want. In this case, we're going to wake up a sleeping thread because we're resetting the delay. And so if you set the delay for 6 days and you meant to set it for 6 minutes, you want to be able to not have to wait 6 days. And then we just return to Golioth that it's successful. And up here, you can see here are my minimums and maximums. So if I go and try to set this value to like a -1 on this device, you can see right now it's set at the project level for 5 seconds. If I change it to like a -1, I should get an error back from this device. And let's just see what this error is. Value outside of the allowed range. So that's kind of handy. And if I throw this away, then I should be able to resync this and see that the device now said it's synchronized because it got number 5, which is the actual usable value. Simple things like backend logging. So we're sending these logs like login. This is just the default way that Zephyr does it. And our backend log is basically like a touchless thing. You turn it on or off in your project SDK. So project configuration file. So here you can see we have config log backend, and it just attaches to the regular logging system and says, hey, when you're sending logs to the terminal, why don't we also send them to the Golioth cloud? And that's configurable by itself. You can use the filtering because obviously in production, you're not going to have these logs on. But there are definitely times where you have a device that's misbehaving in the field and you don't want to have to send someone out to that device. So just turning the logs on for a little while might be able to help you figure out what's going wrong with it. And you could use the OTA update system if you needed to, or maybe just use an RPC to push a new configuration for a misbehaving sensor or a sensor that's kind of fallen out of spec. What do you think, Chris?
This is great. No, I think this is, this is showcasing a lot of the things so this is all of the different services you might want to use. Like Mike mentioned, all the examples that might be useful for your own projects. All of this stuff is in there. This is all open source. You can go and grab this. You can clone the repo, start on your own. Actually, you wouldn't clone it. You would do a West init as the directions on the README says. Or you can use the SDK add-on menu, like Mike said as well. And then it's just down to kind of customizing for your hardware. And then that's the same activity that it would be for any Zephyr project where you want to start adding different peripherals. You want to, change how you're interacting with different subsystems, things like that. And then you get all of the hooks that are on the cloud side that are going to enable lots of different things here.
Yeah, I guess the one thing that I forgot I wanted to mention in this is docs.golioth.io is our docs site. And so all the things that we're going over, the cloud side of them from device management. So if you're like, okay, how do I do a remote procedure call? You can go here and it'll show you all of the things that we've just been showing in doing a remote procedure call and getting those messages back. We also have a firmware. So under our firmware SDK, same sort of thing. So if you want a remote procedure call and you wanted to say, hey, what's the header file that I need to include? you can take a look at that. If you need to see what registering the callback or using the callback functions looks like, you can go and get the information there as well. So we try, for me, I really like to have granular examples. So that's also in our SDK under the examples Zephyr folder. You can go see an example that all it does is an RPC and nothing else, or all it does is send logs and nothing else. So if you're adding this to your project and you just need one thing, you know exactly what you need and what you don't need in the project.
Okay. All of this stuff has been enabled by the firmware SDK, and this is, you know, something we are designed for custom hardware, but really it's we're trying to make the experience as smooth for Zephyr projects as we can. And, you know, not only that, we're also regularly testing against different hardware. So Mike actually has, you can't see it, it's a little off to the camera there, but it's hardware in the loop testers running with a bunch of Nordic hardware specifically. So if you wanted, you know, every time we push a commit to our repo, it goes and tests against real hardware so that you can be certain that we're making sure that this stuff is working against real world hardware, doing a bunch of tests. Mike writes a bunch of great pieces around PyTest and all the automations that we do around it as well. So it's super, super useful. The stuff that you've been seeing, you know, on the bench, on this, the stuff that's in here as well. So all of our firmware is currently open source. All of our hardware will soon be open source. So if you need a reference design platform to build on top of, in addition to the wonderful development kits that are coming from Nordic, this stuff will be another kind of starting place for you. And then you can also start to plug in other sensors like we showed. We talked about microelectronica. Having a bunch of, you know, they have 1,700 and counting click headers that you can plug in there. So basically being able to switch stuff in there. There's also quick and stemma headers on the board as well. That's actually how we talked at that PCB front panel. So just trying to make it so that it's a super flexible way to try out a bunch of just different stuff before you're going to build your own project. And then when you are, you can actually take these files, which are open source, and use them as the basis for your design if you wanted to.
It's a great roadmap to follow too. For instance, if you start with one version of your device and you have 5 revs of it, you want to be able to build for the latest rev, but also go back and build for other revisions. So we keep a separate repo for our each of our custom devices. So this Elixir that we're showing in the picture has its own Zephyr board definition, but that definition has different versions that you can build for without changing anything in your project. So if you're interested in that, it's a good place to look. We always think of Golioth as a platform that you are prototyping on the same thing that you're going to go to production with, so that there are as few changes and everything's been tested as much as possible before you actually start putting devices in customers' hands or out into installations in the field.
Okay, let's talk a little bit about kind of the data side, right? So now you've got this data, it's on the cloud, it's ready to go, you know, go out to the rest of your team. Maybe you're working with a small team and you have, you know, you're sitting next to your web person. Maybe you have a whole team in a different country, you know, but at the same time, the data is the product, right? So that's kind of what we're talking about here. And one thing that I think about when this comes up is just, you want to make sure that, you know, you're focused on the hardware and the firmware, and you're handing data up to the cloud through, you know, lossy channels like Wi-Fi and cellular and all these things. But once the data is there, you want to make sure that that stuff is rock solid. And that's really what a lot of Golioth represents, the rock solid cloud side capabilities. And like I already mentioned with the testing on the device side SDK, the stability of making sure that over time that is still working and still really enables your entire product and your entire team. Once you actually have all this data, you want to make sure that you have, you know, device management, OTA updates, command and control from the cloud back down to your device. That's going to actually extend the longevity of your fleet. It's going to reduce the number of service calls that you have out to the field. It's going to help your company save money, and ultimately it's going to make for a better product. And so that's what we're really focused on and trying to make happen here.
I always look at Nordic as being like all in with the NCS software platform. So you're getting the newest developments, you're making sure that their bugs are getting fixed. And I think Golioth is offering the same sort of thing. Like, maybe you could build your own cloud platform, but boy, the maintenance burden on keeping that updated and keeping it running it gets to be really high and is really a big pain point. So with both of these solutions, you can know that the hardware is going to be well supported into the future, and the cloud side is always going to be well tested, ready for you to upgrade when you need it, or rock solid while you use it.
So this is an example I wanted to kind of showcase, one, because I'm very proud of myself for having done this as a hardware person, but also just because it kind of shows the different steps of where your data might be flowing at this point. So this is actually an example that we have using the Elixir. So this is a different Elixir board that I have here. So it looks same kind of case. It's got a, thank you, Mike. So same kind of case. There's really not much going on in here. There's just no sensors plugged in like you saw from before. It's got a huge cellular antenna to try and overcome my terrible location near towers. But ultimately, in this example, I'm handing Wi-Fi and cellular data up to the cloud. We are showing that data on the console in LightDB Stream, like you've seen on the rest of these demos that we're showing. We're then passing that data using a webhook, using pipelines. And so that's actually the second window down here. And pipelines we'll talk about a little bit more here in a second. And but ultimately, that is taking the data that's hitting the Golioth CoAP endpoints and then routing that out to different places. This is really a data routing capability. In this case, I'm routing that data out to something called N8N, which is a self-hosted program, kind of like a collection of API services and a workflow tool like that. And then passing that data to an API, getting a response from the API. In that case, I'm taking Wi-Fi data, MAC addresses, and their signal strength, passing that to a here.com API, getting a response, getting a lat and long, doing some processing on it, so actually doing a geofence, and then handing that data back down to the device using the REST API. So basically, we can do this kind of like round trip of data out from the device all the way up to the cloud, using a bunch of APIs and capabilities that are out there, and then handing data back down to the device in some cases, or doing other things like sending an alert and pinging on a Slack channel, or using a Twilio API and sending a SMS, or sending an email, or all of the things that you might need to be doing. You might want to be working with your cloud team to use internal processes and different APIs and things like that. But ultimately, you as a hardware firmware engineer are now enabled to do so much more of that. And this is just one tiny, tiny sliver of all these things that are possible by pipelines, which you'll see on the next slide here.
If Chris can do it, anyone can do it.
That's about what I'm saying here. Yeah. Yeah. And so, this is pipeline's a new capability here. The way our head of engineering describes it is kind of a custom API for your devices. And so like Mike showed with the sensor, we're publishing to a sensor topic, basically. Mm-hmm. You could take the sensor topic data and send that to a different place than you might be sending that Wi-Fi location data. And all of this stuff can be sliced and diced and reworked and reconfigured and sent out to a wide range of different teammates and destinations. And ultimately, this is going to enable, once your really nice, solid data has gotten from your device up to the cloud, all of the things that you can do with it is now enabled by pipelines. And this is really the future of Golioth and where we see a lot of interesting things happening. Golioth has unlimited devices on our platform, so you can add as many devices as you want. This is a new pricing we announced a couple of months ago. It's actually a usage-based model. And so there's a ton of data that you get from per month logging, per month OTAs and capabilities there. And same with RPCs. All of this stuff is possible using Golioth. All of our pricing is transparent. It's on the website. You can go to golioth.io/pricing and see all that stuff, including volume pricing. So, it's going to be, if you're doing 10 devices in a test case, it's not going to be that big a deal. But I can guarantee your boss at some point is going to be like, well, how much is this going to work when we put our 100,000 devices on the platform? You want to know that. You could start to build up your spreadsheets, talk about your per device, per day, per week, per month, and then start multiplying it up and seeing how much, the price breaks, just like on a DigiKey or similar. All right, so we've shown you end-to-end demo. We've shown you how you can replicate this yourself using follow-along hardware. We've shown how you can extend this onto custom hardware, how you could maybe rip out a sensor, try a different one, and ultimately how you could take that data and do interesting things with it. But this is not where it stops. You can also follow us and join our training. We have free training every month. We have one coming about a week. We do them monthly, but it's also self-driven, much like Dev Academy. Training.golioth.io is available anytime. And we actually even have some tooling in the browser, so you don't have to even install Zephyr tooling right away, but then it will transition you into having Zephyr installed on your computer. So we think it's a great way to get started, bootstrapped up, and we're really excited about all the people that have come through our training and learned about Zephyr and Goliath and Nordic devices, because we use Nordic devices in all of our trainings as well. So thanks so much for being here today. We really appreciate it. We love, we're going to keep building new stuff for Nordic devices and NRF Connect SDK. And thanks for having us. And we'll hand it back over to Tiago now.
Thanks, Chris. Thanks, Mike. That was really, really exciting. The stuff that you guys are doing at Goliath. I mean, yeah, I hope everyone has enjoyed, because I certainly did. Right, so let's move over to Q&A, and let's address as many questions as possible that have been coming in during the webinar. All right. Thanks, everyone who attended. So I have Marco Puric, I hope I'm pronouncing that correctly, from Goliath with us this morning. And Marco, maybe you could introduce yourself quickly to the audience.
Good morning. Good morning, everyone, and thank you for joining us for this webinar. I'm Marco. Tiago, you pronounce it sort of correctly. I'm from Croatia, and I'm an embedded software engineer, and here at Golioth, I work in the field application engineer role, so helping our customers to integrate Golioth into their production and development environments.
Okay, so I guess you use these reference designs quite a lot in your day-to-day.
Yeah, exactly, for prototyping, proof of concepts, and as Mike said, generally for reminding myself about Zephyr and how stuff works.
Exactly. Okay, so there was someone who had issues with the sound in the questions. I hope you got that sorted out. Normally, restarting the browser tends to, or refreshing the window tends to work. Actually, I only had one question, so I'm going to put it up because it's a little bit long. Yeah, so I'll just read through it before we go to the answer. So that's something that I wanted to measure a customer non-standard quantity. For example, I might want to use my own object detector to report back the occurrence of specific objects, say wildlife. How would I do this? How would I make my own sensor running on dedicated hardware and then interface in a standardized way with one of your devices so that they can report back the object detection to the cloud? Or would I connect my camera directly to your device and run my detection algorithm on your device? So that's a quite loaded question. I think we need to, there's a bit to unpack here. Maybe we start with the last part, talks about camera. So the Nordic devices that are in the market today, specifically the cellular devices, they don't have a camera interface or a high-speed camera interface. Some cameras support SPI, so you could use SPI. And there's really no reason why you can't run a machine learning model to detect certain features in the image. But it really depends, what your requirements are, right? And if you're trying to detect things where your machine learning model is so large that it won't fit in the dedicated flash for the application processor, or it won't fit into the flash, or the RAM requirements are not sufficient, then you probably need to use a sort of a Linux capable device like a single board computer. But then looking at the first part of the question, how would I make my own sensor? So one thing that the guys mentioned during the webinar is this sensor API or subsystem in Zephyr, right? So it really depends what type of sensor it is, but the idea here is that with that sensor API, you can add new sensors, new drivers, and then even have those, you issue a pull request and add those to Zephyr so that the next customer doesn't have to add that sensor as well. But if you use a sensor API, basically abstract your application from the underlying details, so you can replace sensors much more easily. That's something that Marco, the guys, I know you guys at Golioth do quite a lot, and every day I'm impressed how quickly Golioth is able to roll out these reference designs. And I know that the infrastructure and sort of the scalable architecture of Zephyr helps a lot in that, right?
Yeah, I totally agree with everything you've said, especially with the sensor subsystem and Zephyr. The abstraction layer is quite high, so the learning curve is quite steep, but because of that, you are able to quickly transition between development boards, architectures, and sensor systems you are using on your product.
Yeah, exactly. So yeah, obviously we at Nordic, and as well as our partners at Golioth, we're well aware that Zephyr programming in Zephyr can, or based on Zephyr can be a bit strange depending on your background. If you're an embedded Linux engineer, this will be great for you because it reuses a lot of concepts from Meta Linux device tree and the kconfig system. If you're coming from a more bare metal or low level type of environment, you'll see things that need to be learned because there's more abstraction and more infrastructure. But the beauty of that is that long term, you'll reap the benefits. So yes, you'll have some learning, and Golioth provides training. Nordic has the Developer Academy. So we're rolling out as much training, as much education as you can to help customers go over that learning curve as quickly as possible. But what we get, the feedback we get from customers is that once they go over that and they understand, as they go through that learning curve and they start understanding the benefits, then they can do a few things that I've read, at least, for example, on Reddit, because if you want to know the truth, you go to Reddit, obviously. It's the best place to have unfiltered feedback. So what we see customers is saying there is that they can do more complicated things with less time, less manpower, and a much more easier way. Admittedly, some simple things become not as simple. For example, simple things like talking about GPIO. Yes, it requires a little bit more code, but how often do you need to do it? And once you understand how these data models work, then it will be much easier. And you can do really complicated things, even things like graphics, comms, like what you guys are doing with the backends, right? I mean, you have a backend, and you can send data to the blog over UART. You can send data to the cloud, to Golioth Cloud over cellular. You could also send over Wi-Fi. So you could have, and actually in our SDK we have applications that can be built for both a cellular target as well as a Wi-Fi target. And the reason is that the application is just using IP level connectivity. So it really doesn't matter too much if you're using cellular connectivity underneath that or Wi-Fi. So you can build the same application and really decouple the application from the underlying transport mechanism. So yeah, I think we went a bit longer than answering the question as such, but hopefully there was some good information in there. Yeah, so we didn't have any other questions, so I think we can close the webinar now. I'd like to thank everyone for attending. We have another session in the evening. If you want to still ask questions, you can join that. Of course, then you have the Golioth forum for any follow-up, or the dev zone for any follow-up on the Nordic side. And I hope to see everyone at our next webinar. So thanks for joining.
Thank you, everyone.
Bye. All right. Okay, so yeah, thanks guys for the webinar. This is great.
Thank you.
I'm always impressed by the amount of reference designs you guys spin off based on the 9160. There's just more and more coming. So yeah, keep them coming. All right, so we have a few questions. Let's go through those. So the first question is actually related to the NRF91 series from Nordic. So the question is, so with the new NRF91 series devices coming out, so what is the future of the NRF9160 for customers that are already using it, which was the device that you based this content on? So essentially, we're committed to the NRF9160. It's the most mature cellular IoT product from Nordic. It was launched in 2018, so it's been out there, tested, beaten by many customers, many applications, hundreds of customers. I mean, the stuff that you guys are doing is a good testament to that, right? How reliable it is. So that we're not adding new features to the modem firmware. So that is the 1.x version of the modem firmware. I think the latest is 1.3.5, if I remember correctly. We'll continue to make new versions for bug fixes and updates as needed. If there's any changes to the cellular carriers or things like that we need to update, we'll continue doing that. And the longevity is essentially as long as there are customers buying the part, Nordic is committed to maintain. That's like the general statement that Nordic has about products. Just for reference, we're still selling the NRF51, the very first wireless SoC that came into the market over 10 years ago. But of course, with the new devices, so essentially, if you're starting a new design today, then our recommendation is to start based on the NRF9161 or the NRF9151 for cellular IoT. Of course, there's also the NRF9131, the smaller one. That's not pre-certified for cellular. It's more of an option for Technar Plus, but if you're doing that large volumes, which would be great, and you can do the certification, that's also an option there. And you guys are already using the 51, right? The NRF 9151. So maybe you can tell us a little bit about how the transition went from the 9160 to the 9151.
Mike, you did all the work.
So. I was lucky enough to have a pre-release version of that board on my bench, and excited that it was the first Nordic board I've had that has USB-C on it. And generally, I think Chris was excited by the size of the new.
Yeah.
So it's very easy to work with, and the support is already built in and tested into NCS, which is a great benefit of it. And we got it up and running on our platform. Kind of like with all devices, like once you get that network connection and get the Golioth module built in, it looks like all the rest of the devices you're working with. So quite exciting for the future.
Right. Yeah, because I mean, once you're on top of IP, it doesn't really matter that much the underlying hardware, right? And actually, as an additional sort of extended example, we have samples and applications in the SDK, which are IP-based samples that can build for either a cellular target or a Wi-Fi target with the NRF 7002 companion IC. Yeah. So that's just into the flexibility of Zephyr, having an SDK built on Zephyr and having that flexibility and scalability of having the abstraction. It really helps in the long run.
Yeah, we use that 7002 DK in our training. We use NRF 52 with a cellular offboard modem in our tests, and so really any Nordic board that you can get network to is going to work. That includes the new Nordic border router. So if you're looking at doing thread works with Golioth as well. I think it's kind of magical when you have a little thread network of nodes seeing firmware updates being pushed down to those.
Yeah, the wireless is close to magic for a lot of people. So just convince them that it really is. All right, so the next questions are actually on Golioth. So I'll just read them out loud, and I'll hand over the microphone to you guys. So the next question is, how do I handle connecting devices that use different hardware configurations to Golioth?
All right, so I'll take that one as well. This is a common question because you tend to have fleets that are not homogeneous. So you don't have just one type of hardware that's in them. And so Golioth generally organizes devices into fleets. We call that at the project level. You could have multiple projects, but even within a project, we further kind of organize your fleets by something called blueprints, which is a kind of set of what does the hardware configuration look like. So all of the boards that want the same hardware configuration might be assigned that blueprint. And then if you're pushing over their updates, you would target it at that blueprint. We also have the ability to organize fleets by tag. So you might tag different locations, different buildings or plants, different levels, different services. We also, we target release candidate tags. So instead of rolling out an OTA update to your entire fleet, you roll it out to a few of your release candidates first, make sure everything is going the way that you thought it would, and then open that up to further devices. So I think as far as that organization, it kind of drills down to usually what's the firmware look like. Everything else, all the rest of the services, as soon as they're connected to Golioth, it should look and work the same from the cloud side. And you can choose in each different firmware what services you want to build in and what services you want to leave out.
Okay. All right. I think that was a very comprehensive answer to that question. Two more questions. So one is, does Golioth only work with on the NRF 9160 for Nordic parts? Well, we kind of partially answered that. It also works on the 9151 and over Wi-Fi. And of course, there's also non-Nordic part support, right? But I'll let you guys elaborate on this answer.
Sure. I mean, we do have stuff that works across all Zephyr, but Nordic is some of our favorite parts out there. One thing that's exciting is we're doing some early work on Bluetooth as well. So Bluetooth stuff talking through a router up to the cloud. That's another thing that might be interesting to Nordic customers. If they are, they should definitely reach out to us. There's some early work on that. And, we think it's really exciting because, the number of times, Thread is great for sensor networks, Bluetooth mesh, which we've written about, also great for sensor networks, but really Bluetooth through some kind of gateway, that's what we see as a really critical feature. So we think that it's got some legs, and we've been doing a bunch of experimentation, and we have some very, very interesting prototypes on our benches.
Yeah, I saw that myself at Embedded World because I had the Zephyr kiosk just next to you guys, and you had the Bluetooth mesh demo. That was really cool.
Yeah.
With all the that's the one that had the microbits, right? They had this little board that inserted the microbits. Yeah, you did a blog about that. It was really cool.
Mm-hmm. Yep.
Okay, so I think we'll take last question, and if nothing else comes in the meantime, I think we can then close the webinar. Yeah, so last question. Actually, this is an interesting one. I'm curious to know the answer. So, what is the process of using Golioth with existing projects? So you have a firmware developing, and now you want to add Golioth, right? So maybe you can walk the audience a little bit how that would go.
Yeah, so generally speaking, with our reference designs, they're going to be based on the importing the manifest from the Golioth SDK, which then imports NCS. But that's not the only way to do it. If you look at the README that's in our SDK repository, I think it's under examples Zephyr README. It shows you like just the little project module that you add to a manifest file. And so whatever your manifest file is, as long as you have NCS available, and you have a network connection up and running, adding Golioth is really just plopping something down on top of that. The one important thing is that we make sure that we test the releases of NCS. So you should take the time to match the release of Golioth to the release of NCS that you're using. But as long as you have that matching, everything should turn on and work just the way you like it. Obviously, we're happy to talk about the things you're building, and any questions you have, you can always send them to devrel@golioth.io and or check out our forums. Forums.golioth.io is another great place to look where other people are adding to their own projects and just to ask questions, because we don't want you to get hung up. We'd like to get you unstuck as soon as possible.
Yeah, makes a lot of sense. Yeah, the modularity of Zephyr is really great. I mean, it's like trying to build a house and have all these Lego blocks, right? So that's what Zephyr really enables. It's really exciting.
And we're really big proponents of, digging in more. Like I think Dev Academy talks about West Manifest a bunch. Mike's done a couple conference talks about it. We just think it's definitely one of the best parts of Zephyr, and the ability to, maintain as you go through production too. Like it's just being able to lock to different versions. And I don't know, the way that we talked about this a little bit in the webinar here, but just having that as a methodology generally, even if you don't do it the way we do it, there's a bunch of Zephyr documentation, Nordic documentation, Golioth documentation about how to do that. And I think that for people that are serious about making, products that have longevity, have really well-developed firmware, it's a good way to start operating.
Yeah, indeed. I mean, when I went to look at, feedback on the SDK, I go to Reddit of all places, because that's where you get the most unfiltered,
you are very brave.
Unfiltered truth, right?
And
of course, we know that there's a steep learning curve to Zephyr and to NCS by extension. That's why we have Dev Academy. For those who don't know, academy.nordicsemi.com, you have courses for the SDK, just sort of the fundamentals. A lot of it is on Zephyr, obviously, the infrastructure. Mm-hmm. Things we're discussing here, kconfigs, West manifests, device tree, and so on. And then sort of protocol-specific courses for Wi-Fi, cellular, and Bluetooth. Some of the things that I see there is that customers, once they go through that curve, it's like they see a whole new world on the other side, right? And then sometimes you read things like you can do more with less. Essentially, you can do really complex things, and you can deploy across different versions of hardware, different devices with ease that it's difficult to find in other environments. So that's really the power of Zephyr. It just gives you so many options.
They get so into it, they become Zephyr ambassadors, like our own Mike Stish here. So Mike is
yeah, exactly.
Ambassador.
Yeah, exactly. And they go to Zephyr developer summits and all, right? To give talks.
Exactly. Yeah.
All right. Yeah, I mean, I think you're absolutely right, though, Lady. It really does unlock. I think project stability is a big part of it. So I have a fleet, it's out in the field, it's running firmware. I need to be able to get back and troubleshoot at that version. But then also, I am moving forward. I'm upgrading. The revision control and the ability to manage a complex chain of dependencies it makes me sleep at night.
Yeah, exactly. Yeah, it once you grasp the tools and how to manage them, it really helps you do things the right way, right? And I think that's key to Zephyr, that you can do Zephyr in a bad way, and yes, you will struggle. But if you do Zephyr the right way, the way that you guys are doing it, and a lot of our customers are doing it, then you will see that it's not that difficult once you learn it, and then you'll just you'll reap a ton of benefits out of that. So those were the questions. Nothing else came in, so I think we can just thank our audience for attending today. And of course, thank you guys for joining and doing all those great demos. I hope we can do more things together moving forward. Of course, you're always exploring new things. You're using a lot of Nordic devices and solutions, so that's great. So I think we can close it here. Thanks for joining. Thanks, Mike. Thanks, Chris. And I hope to see everyone back at new Nordic webinars, or of course, other Golioth webinars. You have one every Friday, so it's hard. It's really hard to keep up because you guys are always online, it seems.
Yep.
Right. Okay. Thanks, everyone. We're going to close it now.
Thanks.
Bye-bye.